Hello everyone, welcome to this video, which is part of a series of videos on supply chain network design and the analytical models that are used in supply chain network design. We talked about the basics of supply chain network design, and I introduced you to the first gravity location model, an optimization based gravity location model in the previous video. In this video, we'll talk about a recursion based gravity location model. Now this will have you do a little bit of work multiple times, but you'll notice that the final solution, it won't end up in the exact same place, but it's not too far from where we ended up with the other model either. All right. Okay, so how do we use this model? Now, just like the previous case, you'll notice that we had to calculate distances, so we're going to do that. But we're going to use the recursion to calculate exactly where we locate this model. We'll locate this number. Now, this is actually very close to how you actually find centers of gravity. So when you're looking at center of gravity, this is basically the way you do it, right? Okay, so there are many things that we have to calculate. So I'm going to open up my Excel file. What I'm going to do is first I'm going to call this tab the optimization model, right? And this we're going to call the recursion model. Did I spell that right? I don't know if I spelled that right. Recursion, does it have 1 R, 2 R? Well, we'll find out when you guys email me and let me know if I spelled that right or not. Okay, now proceeding. So in this recursion model, so I'm going to copy some of this data over. I am in fact, you know what? Let me delete this file. Sorry, delete this tab. The reason for that is I'm just going to make a copy of this tab. So I'm going to click on move or copy, create a copy, move to the end, and let's take it from there. Now the reason why I wanted this was that the distance formulas are already in, so I don't want to redo the distance formulas again and again. That's the reason why I copied the file. Once I write the distance formula, there's literally no reason for me to redo the distance formula, right? Okay, so let me see if recursion is spelled correctly. Nope, it is singular. Okay. All right. In this case, cost is not going to play a role, so I'm going to get rid of cost. Cost is not important for us. Get rid of that. This is just no fill. All right. And I do not want any borders either. Okay. All right. All right. So we start with nothing. So everything is 0. So we have our distances, right? We have the x coordinate, we have the y coordinate. So to implement this, we have to do some calculations. So the calculations that we have to do is the formula for the recursive x is you have to calculate this behemoth and it divided by this behemoth, right? So dn times fn divided by small dn. So this is something that we have to calculate. We have to multiply that with the x coordinate and then divide by the sum of the whole thing. So there's a lot of things to be done here. So what I'm going to do is let's do that calculation. So what we're going to do is let's calculate capital Dn, right, times, so the formula here was capital Dn times capital Fn times xn divided by Dn. So I'm going to leave xn for the time being. We're going to do capital Dn times capital Fn divided by lowercase dn, right? So let's do that first. All right. So let's do this calculation. So this is just right here. Dn times the cost divided by the distance, right? So we have that. Just gonna copy the numbers over. 4 is fine, right? So why is this useful? So if you look at the formulas that we have, this is just the sum of dn fn over dn for all possible values, right? So that's basically what that is. Now in the numerator, you're multiplying this with xn and then adding up all possible values, right? So if I add up all of these numbers, that is what I have in the denominator of the formula. Now I have to calculate the numerator, right? So the sum of all of this is the denominator for my formula. But if you look at the numerator, so numerator is, so I multiply this number with xn, that will be the numerator for x. If I multiply this number with yn, that will be the numerator for y. So let's look at the formula. If I multiply this number with xn, that's the numerator for this. If I multiply this number with yn, that's the numerator for that, right? So I have to get this numerator, I have to get this numerator. And once I have that, I can add these numbers up, divide by the corresponding numbers, and then I have my formula. So let's do that. So next, we will do dn times fn times, right, xn divided by dn. So there are a couple of ways of doing this. One is I can just multiply these numbers together just like we did before, but instead, because this is already that, I'm just going to take this here and multiply this with xn, right? And this will be yn. Oops. There you go, right? So I have the xn values, I have the yn values. Now the x value is, now let's sum these. What I'm going to do is let me insert a row here. Just move everything down one level. So that way I'm going to say sum of all of these numbers. Now obviously there is an empty row in the middle, but that is 0. But when you're adding numbers, 0 doesn't matter, right? So I'm just going to do this throughout. Get rid of that. Okay, so I have my value. So the x coordinate, so in this case will be x prime y prime. That's what they're called, right? X prime y prime in the formula. Yeah, x prime y prime. So this is going to be the numerator divided by the denominator. Nice. Right. Oh, yep. I missed it. Give me a second. So now, so this is, so we need to have x's and y's, and on top of that, we need to have x prime and y prime. I'm sorry, I missed that. Right. And y prime. Right. So we have x and y, and then we have x prime and y prime. Now, these x and y's are used in these formulas, so you cannot refer to them again. That was that whole circular thing that I was talking about. Yeah, I missed that for a second. So this is the numerator divided by the denominator. Oops, these are not dollar values under any circumstances. Should just be numbers. Right? In fact, I'm just going to get rid of the decimal place. Right? And this will be numerator divided by denominator. All right. Now, so the way this recursion works is when you start this formula, you started with, let's say 0 and 0. You have nothing there, which means that it's 0 and 0, right? So you started with the warehouse location at 0, 0. Then once you did the center of gravity calculation, the location turned out to be 585, 762. Right? So 0, 0 and 585, 762 are obviously not the same location. So when these numbers here and these numbers here don't match, then you have to continue the recursion. What does it mean for you to continue the recursion? What it means is that you take the number 585,762 and now make that your current warehouse location. So I'm going to copy these two numbers, right? I'm going to paste that there. Oh, right. I can't copy that because they have a formula. So I'm just going to copy, I'm going to type them in. That's it. 585, 762. Those were the two numbers, 585, 762. Now, once I typed in 585, 762, you notice that x prime comma y prime also changed because all the formulas that you here got recalculated, right? Now, you'll notice that the difference between 0, 0 and 582, 765 was much higher. Now, 611 is much closer to 585. 804 is much closer to 762. But still, they're not the same numbers. So now what do you do? Well, you take the new x bar, y bar, and make them the x comma y. So again, you started with 0, 0. You found out that x prime, y prime was 582, 762. So you just copied the numbers. And do the same thing. 611, 804. So 611, 804, right? Now you'll notice that these two numbers are much closer to these numbers compared to the original. But they're still not the same. 631, 829. Closer. 645, 845. Oh, 848. No. 645, 845, I'm sorry. Closer again. 655, 856. Right? 662, 863. Much closer. 662. Right? So 667, 868. Closer. 671, 872. Much closer. Right? So they're within 2 of each other now. Now you can decide to stop here. You can say that, hey, this is close enough for my planning purposes and this seems like a good location for me to place it, and you can stop it here. Or you can keep going, right? 676, 877. Ooh, this is within 1, right? 678, 878. Oh, 679, 879. Now this is 679 and 679. This is the only one that changed. Right? So at this point, you can decide to stop, right? So 680, 880. So let's try the last one. And this is where I'm going to stop. 680, 880. So this is the location for the X and the Y coordinate of the warehouse. Now this is within a mile of this location. You can keep going and keep doing this till the thing converges, and mathematically you can show that the convergence will happen. You might take multiple iterations to there, but this is the recursive method, right? 680 comma 880 versus 681 comma 882. So let's see if this happens. So 681 882, right? 681 882. See? Now the numbers are the same. 681 882. But that will not always happen. Now this is a case where the two things converge together, but that will not always happen. So this is the location for the warehouse, 681 882, and we know that it's going to cost us $1.265 million. And that's the recursive method. So you can either use the optimization method or you can use the recursive method. And yeah, this is the gravity location model. So gravity location models are useful when you're locating individual facilities, right? Now, in the next week and the weeks on, we'll look at the problem of locating multiple facilities together. When you do that, the first thing you have to realize is that how did we come up with this menu of multiple facilities, right? So the menu of multiple facilities, well, you came up with that by using the gravity location model to size up each individual facility. And then figure out, well, does this make sense? Does this make sense? Where exactly should we locate it, and so on. So once you make those decisions, that's when you once you look at the individual facilities, that's when you look at the menu of facilities, and then you look at the larger considerations of supply chain design, which we will get to in further weeks, right? So I'm going to stop this video here, and I hope if you have any questions, I hope this was clear for you. If you have any questions, please feel free to email me, and well, I'll see you all in the next video. All right, take care.